In the previous video, we simulated an attack in Kubernetes environment to understand what attackers do when they gain a foothold on a pod. There we escaped from the pod to gain access to the host, and then we gained persistence there. In this way, we generated some sample events that we can analyze in this video. First, I want to talk a little bit about incident response in Kubernetes in general, because in this video we are just focusing on disk forensic. And then I want to talk about container forensic process, and then we will apply this process in our hands-on lab in the last section. So how can we respond to security incidents in Kubernetes environment? To me, logs are the most important artifact that we can use during the incident response. We can install Falco, for example, there to even prevent to stop the attackers. We can collect different logs, syslogs from the worker nodes can be very useful. We can collect NetFlow logs and build all of our detection based on this log source. GuardDuty also has some features, some detections available for Kubernetes environment. We can also enable them. And also cloud audit logs, like CloudTrails, can be very useful there. For example, if attackers can find the AWS secrets in the pod or a host, they can use them to create new EC2 instances or new resources. There we can really use CloudTrail logs to see what has happened there. One other important log source are the logs that Kubernetes environment generates for us. We have API server logs, audit logs, authenticator logs, control manager logs, and scheduler logs. For example, with API server logs, we can see all the API calls that happened from the pod or node. For example, if new pod is created, or list of the resources were listed in the Kubernetes environment. Or in audit logs, we can see what has been changed. For example, attackers might make some changes in the Kubernetes environment or create a new cluster. All of these things can be captured also in Kubernetes logs. In my experience, if we collect these logs, for most attacks, we are good there. But we cannot stop there. There are some APTs there that we might want to dig into the analysis. So live forensic can be one solution. For example, we can connect to a pod or node and there collect some artifacts. For example, we can write a script that collect all the important changes in the files. For example, the cron jobs and this sort of list them. So make a summary file and send it to you. And then you can quickly check that file to see if anything off is there. Memory forensic can also be interesting. So if you want to do memory forensic, my suggestion is that we need to create a memory dump on the worker node, not on the pod. In the end, pods also are processes in the worker nodes, right? So take a memory snapshot from the worker node and do all the analysis there. The other thing is disk forensic. That's what we are going to do in this video. And I also wanted to point out another technique, which is Kubernetes checkpointing. Basically, with this technique, you can create a stateful copy of the running container, and then you can move it to your lab or forensic environment and do all the interactions there. That's also very interesting because then you don't need to interact much with the production environment. Let's focus on disk forensics because that's what we are going to focus in this video. Let's go through the process. In normal cases, we have a suspicious VM, we create a disk snapshot, and then we create a disk from the disk snapshot and attach it to our forensic machine. We run Plaso to create a timeline, and then we can analyze it using different tools. For example, we can use Timesketch to import a timeline and do all the analysis there. Or we can onboard it in our SIEM and do all the log analysis there. We can write even playbooks there ready for analyzing and finding suspicious things in the timeline. For containers, we need to do one more step though. We need to mount all the disk or file system of the container to your machine. You can use Container Explorer for that, and then you run the Plazo and create a timeline. So there is one extra step that you need to take if you want to analyze create a timeline and analyze it for the containers. I'm gonna show it in this video. So in this video, we will use the attack that we simulated in the previous video. Our environment are very simple. We have an EKS cluster, one EC2 node, and we have an Nginx pods running there. And as you can see in the previous video, we simulated an attack, and now we want to check it based on the process that I just explained. Okay, so we will start with creating a disk snapshot from this machine. I don't need this server anymore, so I will first stop it and then I started a whole process. What we need to do here is to go to the disk of this machine. So storage, here there is one volume attached to it, and we are gonna create a snapshot. So we call it forensics disk, forensic snapshot. Here we go. So we create a snapshot, and as you can see here, the availability zone is US West 2A. It's gonna take some time to create this snapshot. So here, as you can see, it's still pending. We need to wait for a few minutes until this process finishes. Okay, the status finished. So what we are gonna do, we are gonna create a volume from the snapshot. Here we are. We check US West 2A. This availability zone should be similar to your EC2 instance. So that looks good. I also add a tag, name, forensics. Here we are. All good. So create a volume. The volume is here. So I'm gonna attach it to my forensic machine. Here you are. We check this one and attach. So this is my forensic machine, and if we check it to see what sort of disk we have here, sudo f disk -l. Okay, these are too much details, so we can use another command to see better details. So for example, we can run this command. Here we are. So we attach the disk of the worker node to our forensic machine. But before doing all the forensic, I'm just wanna install few tools like first Plazo, and then also I also need Container Explorer. So I will move forward by installing Plazo. You can see the how you can install Plazo here on this website. Basically, there are just few commands that you need to run. I will start running this command then. So, and then we need to run this command. Okay, so by running this command, now we should have Plazo on our machine. So let's check it again. First, all of these commands should be executed. Yeah. Okay. Uh, awesome. So let's see if Plaso work. I just run this command. Awesome. We see that psort working. There is another tool that we need to install, which is called Container Explorer, which is managed by Google team. Basically, we use it to mount a container this to our machine. The installation is easy. Basically, we can here you can see all the details. You need to run this command, and then when you have the setup.sh, you can install it with the other command. So I'm gonna do that here. First, I download the file, and then I go ahead by installing it. Awesome. So if you want to see the help file, you can just run this command. And as you can see, it has been installed without any issues. So now we have this Plaso that help us to create a timeline, and also Container Explorer installed in our forensic machine. And we also attached the volume of the worker node to our forensic machine, and it was here. If you run lsblk command, you can see it here, and this is the worker node disk. Here I'm gonna create a folder. It's called forensics, and I'm gonna attach this one there. So let's do that then. Sudo mount. I will do it read-only to just make sure that we don't execute something by mistake, or we don't change evidences of any evidences in our EC2 instance. And then I need to pick this one. Okay, sounds good. Let's see if this works or not. So if we go to mount forensic folder, we should be able to see all the files that existed in the EC2 instance or worker node. Let's do a quick peek on it. So the first thing that I usually do during the forensic is to check all the executed command on the machine. So I just go to home EC2 user bash history to see what we've executed. If you can recall from the simulation, when we gain access to the EC2 instance or worker node, we executed these commands. And as you can see, they existed in bash history. So here we can create a timeline for the worker node using Plaso, so which help us to understand what attacker have done after escaping from the pod to the node. I'm gonna skip that because that's exactly same as a container, and I will focus on creating the timeline analysis of the actual container. But in real attack, you need to also create a timeline for the worker node and analyze it. Okay, Now it's time to check the pod. For that, we need to use Container Explorer. First, we need to list all the containers on this machine. So what you need to do, this is Container Explorer. We say, okay, in this folder you can find our worker node, and this is a YAML file that exists in the Container Explorer. We want to list all the containers without showing their labels, because if we show the labels, it will be a little bit messy here. Here we are. So we see two Nginx server, and as you can see, one of them was installed from Docker. We will focus on this container. So we need to pick the container ID and use it to mount the file system of the container to a folder here. So first I will create a folder which is called mount container, and then I'm gonna mount the file system of the container to this folder. So here we need to pick the container ID, put it here, and then we need to also pass the folder that we want to mount the file system there. So I'm using Container Explorer to extract all the file system of the container. And if you go to mount container, you can see all the file system of the container. If you can recall from the simulation, we downloaded the beacon file from the attacker's machine, and here you can see it. So if we say cat mount container beacon file, you need to use sudo. You can see the code that attackers are using there. So in this way, we know, okay, that attackers are using it in some sort of beaconing activity. We can dig into that more, or we can, for example, check the bash history. So let's do that also for the container. And here we are. So we see all the commands that we have executed when we gain access to the pod. Like we checked passwd, the shadow file, we installed some files there, we ran beacon, and also we used this technique to do privilege escalation and also gain persistence in the worker node by adding our public key to the authorized keys file of the worker node. So by just looking at these files, we already know what has happened. But in real attacks, this is usually more complex than what we see here. So we want to use Plaso to create a timeline for the container. As I said, you should also create a timeline for the worker node, but as the process is similar, I will skip that part. So I will use log to timeline to do that first. So it's gonna take a few minutes. So when we have that timeline.plaso file, we need to start to use psort file to create an actual timeline in CSV format. Awesome. So let's the previous command that we ran was log to timeline. So what we need to do here is to run the psort command. So let me do that here then. Awesome. So here we are. Timeline.csv file. This file has all the details of container. What we need to do here is to what I usually do from my laptop, I just copy it to my laptop, and then I use Timesketch to analyze it. So let's do that then. Okay, so let's copy the file on the on our machine, and then we can upload it in Timesketch to analyze it. You need to install Timesketch. It's easy to install it. You just need to run few commands. So Timesketch installation. I installed it before to just save some time, but installation is super easy. Basically, you need to install Docker and then run these commands to install it. So there are just 3 steps, and the 4th step is just enabling TLS. I've already done that to just save some time. So here we are. Now I'm in Timesketch, so I'm gonna import the timeline here and do just quick search to show you how you can check the timeline. So let's create a sketch first. We call it EKS Forensics. And then we need to add our timeline there. That's the timeline that we created using Plaso. So here we go. Submit. You can write a lot of plugins or use the existing plugins there to do the analysis. There are some really good plugins there that you can use. You can find it, for example, here there is a stories, search templates, Sigma rules, thread intel if you have. There is also here that these are all the plugins that you can use. For example, account finder if you want to check the browser search terms. If you are using Windows, you can, for example, find event caps, because attackers sometimes remove events there. So you can use all of these things. I'm gonna focus on the search. I'm just here. I'm not gonna do a lot of digging into logs. That's out of the scope of this work. And I'm gonna just limit the time to last 7 days, because that's where we simulated an attack. Let's just, for example, search some of the things that we've done during that attack. For example, app install. Here, if you go, here you can see which application have been installed recently. That's the command that we have executed. Or we can also check some of the commands that we executed and see that there are some traces of them here. For example, list bulk before mounting it. Or let's search for mount, and you can also see more details here. Yeah, you can see that a new mount has been executed, and what I'm trying to say is that here you can find all of the evidences in the timeline and quickly search it, especially if you prepare your plugin there and you just run the plugin, it automatically analyzes all the actions that we have performed. Or we can, for example, check the shadow file that we have touched. So as you can see all the evidences of the activities that we've done here. This is just show you how you can use Timesketch to do the analysis. So the whole process, if we want to review it again, we created a disk snapshot. We attached it. We created a disk from the snapshot, attached it to our forensic VM. We used Container Explorer to mount container files here, and then we run Plaso to create a timeline, and then we analyze it using tools like Timesketch. Or you can just onboard the timeline in your SIEM and run your query or notebooks there. So this gives you some idea about how you can use disk forensic in Kubernetes environment. Thanks for all your attention.